Hi everybody, this is going to be our note for 5.1. We're starting chapter 5. We're going to be applying primary trig ratios. So before we get started, we have to do a little bit of review on triangles. So recall, for triangles, angles in a triangle add up to how many degrees? Correct, 180 degrees. Sides are opposite to their corresponding angle. And what we mean by that is if I have a triangle here, angle x here, well, the side opposite to this is just a lowercase x. We have a capital Z on the angle here. Opposite to angle Z is going to be a lowercase z. That's a bad z. A lowercase z. And this is angle y, so opposite angle y is going to be side y, which is a lowercase letter. So we use capital letters for angles, lowercase for sides. We also learned about the side of a right angle triangle called a hypotenuse. Hypotenuse is the longest side. I heard somebody say it. And it is opposite of the 90-degree angle, or the right angle. Put it in brackets. So which side in this triangle is the hypotenuse? Well, here is the 90-degree angle, or the right angle. Opposite of that is the hypotenuse. So used to find side lengths in right triangles, we use Pythagorean theorem. So here's our example. In this triangle, x, y, and z, if x is equal to 9 and z is equal to 6, find the side length of y here. So remember, x we said is the hypotenuse. So for us to use Pythagorean theorem, we have to know the hypotenuse. So remember, Pythagorean theorem was c squared is equal to a squared plus b squared. You might have known it as a squared plus b squared equals c squared. They mean the same thing. So I have the hypotenuse though. I have x. What I need to solve for is y, which is one of these other measurements. So we're just going to substitute x for the hypotenuse, which is usually c. And then I'm going to put y squared plus z squared. So I want to figure out what y is going to be. I'm going to isolate for y. So first thing I'm going to do is I'm going to move the z to the other side. So we get x squared minus z squared is equal to y squared. Then I'm going to put in the numbers. Well, we said x is equal to 9, so x will become 9 squared. We said z is equal to 6. This will be 6 squared is equal to y squared. And if I simplify it like this, I'm going to get 81 minus 36 is equal to y squared. I subtract the 2, I get 45 is equal to y squared. I want to get the y by itself. So get rid of the exponent here, I do the opposite, which is our square root. So y is equal to approximately, let's say, 6.7. So the length of side y is 6.7. Keep in mind, I could have put the numbers in first and then did the square roots and then moved it over. That would have been fine too. But I just had to remember that the hypotenuse was x, which was a c squared, and I replaced them, and then I solved for one of the other sides in this question. So a quick review on Pythagorean theorem. I'm remembering what the hypotenuse is, and that we have capital letters for angles and lowercase letters for side lengths, and that the angle and opposite side lengths are the same letter. So let's go back to now primary trigonometry ratios. We used to find side lengths and angles using these primary trig ratios, specifically in right triangles. Right triangles meaning there has to be a 90-degree angle somewhere. So how do you remember what SOHCAHTOA stands for? Well, the SO stands for sine. Sine is the ratio of the opposite side divided by the hypotenuse. And remember, the angle we call theta. Now let's look at cos. Cosine for the ka part, ka, stands for, the A stands for adjacent, which means beside. And the H stands for the same thing, which is hypotenuse. And lastly, tan, TOA, well, we know the O stands for opposite, and the A stands for adjacent. So it's all relative to what angle we're talking about. So here we say our angle is theta. So if I wanted sine for that, I would say, well, opposite to this angle is this side, and the hypotenuse is this side. So whatever my measurement here is, I would put this one over this one. So I'm just going to show these here, just showing the letters. So sine theta, this would be sine. If I wanted to solve for the angle, I would get sine -1, and then multiply that by the opposite divided by the hypotenuse. For cos, if I wanted to solve for the angle, I'd move the cos to the other side. It becomes cos -1, and you get the adjacent divided by the hypotenuse. Lastly, we get tan -1 if I have to move the tan over to solve for the angle, and we get opposite over adjacent. So let's get to an example. Now, some people do have troubles with this section, like if you learned about it before, as maybe you forgot it when we did it last year. So if you need a bit of a refresher, we can do some office hours, we can go over some questions on top of these examples if you want. So it says, solve the above triangle, triangle ABC, if A is equal to 5 and B is equal to 3. So let's redraw this triangle. Right there. And we said A is this, we said B is this, and this is C. So if this is angle A, well then side A has to be opposite it, which would be over here. Side B would be opposite of angle B, and side C would be opposite of angle C. And we have angle C being a 90-degree angle. So just from this, we already know that this should be the hypotenuse, because it's the longest side and it's opposite the 90-degree angle. And they give us the angle measure to be at A. So it says solve the above triangle, triangle ABC, if A is 5 and B is 3. When we say solve the triangle, it means I need to figure out what the other angles are. So I need to find out what theta is. I need to find out what this other angle is. I need to figure out what, well, they give us A is equal to 5 and B is equal to 3. So I need to figure out what the hypotenuse length is as well. So I got to figure out 1, 2, 3 things. So what should I start off with? Well, let's do the easiest one. I think the easiest one is the hypotenuse, because we know the two side lengths here. I just have to use a certain theorem. So to find C, we're just going to say, according to the Pythagorean theorem, c squared is equal to a squared plus b squared. Since we're actually trying to solve for the hypotenuse C, we're just going to sub in what a and b are. 5 squared plus 3 squared. 5 squared is 25, plus 3 squared is 9. C squared 25 plus 9 is 34. And if I take the square root of both sides, square root of 34 obviously is 5.8. So we can say that the hypotenuse length is 5.8. So we have letter C figured out now. So we've done that. So I need to figure out my two angles now. So let's do the theta next. Well, we have the hypotenuse, but let's pretend we didn't have this. Let's say we just had A and B to work with. Well, if I have the angle here, and I have the two side lengths, that's enough information to find the angle. So from angle A here, this 5 is opposite, adjacent, or hypotenuse. Well, it's on the opposite side of the angle, so I have the opposite. And assuming I didn't have the 5.8 here, I would have the B value, which is from angle A, it is actually adjacent to it though. So if I see opposite over adjacent, oh, that's got to be tan. So tan theta is equal to opposite over adjacent. I want to figure out what the angle is, so I'm going to move the tan to the other side. So theta is equal to tan -1 times the opposite to theta, which is 5, divided by the adjacent side to theta, which is 3. I put those into my calculator. For me to do that, I'm just going to do 5 divided by, or I can actually just do, well, here's our sine, cosine, tan. I want to access the tan -1, which is above it, so I'm going to press second function, tan -1. Then put my fraction inside the brackets like that. Oop, I think I did it too quick. Let's just double check. 5/3. And I get 59.04 degrees. So that's got to be the one angle, this theta. So if I know this is 59.04 degrees, I could solve for angle B here, which is that question mark, a couple ways. One way to know is that, well, all three of the angles in a triangle we said should add up to 180 degrees. So if 180 degrees is equal to 90 plus, well, you know, I'll show the whole thing. Sorry. So 180 degrees is equal to angle A plus angle B plus angle C. So if I know A and B, nope, sorry, A and C, I apologize. If I know A is 59.04, I don't know what B is, and I know C is what we solved for before, which is, no, sorry, it's a 90-degree angle. I'm just going to isolate for B. So I would get 180 degrees plus, so 59.04 plus 90 is 149.04 plus B. I would subtract 180 minus 1.0, this is equal to this. And if I subtract those two, I get angle B to be 30.96 degrees. So that's how we get B, that's how we got our theta, and that's how we got our side length. Keep in mind, if I knew the angle measure here, I could have found this angle measure using any of these trigonometric ratios as well. So a lot of different ways to do it. We just have to remember what our ratios are. Remember SOHCAHTOA. We should be able to label a triangle to know what's the hypotenuse, and if I know a reference angle, I should be able to know what is the opposite and adjacent side to that. So this is a lot of review. Hopefully it's not going too quick. If it is, again, please work out at office hours with me so I can help you, because I think we can get it together if you are having a bit of trouble here. So before we move on, we have to remember two kind of terms for angles. One of those terms is an angle of elevation, and one is an angle of depression. Elevation just means when we look straight forwards, like there's a person looking straight forwards, and angle of elevation is above your line of sight, and angle of depression is below your line of sight. So think of, it's not the best way to, if you're depressed, you feel down. I'm not trying to make light of depression at all. I just think it helps us remember that an angle of depression means going downwards. And if you're an angle of elevation, like an elevator, you go upwards. And elevators can go down, but you know what I mean. So elevate means to go up, and depression means to go down. And it's all based on your line of sight looking forwards. So we'll keep this in mind when we're doing our next word problems. Speaking of word problems, here we go. While flying a kite, you let out 150 meters of your kite string and anchor it to the ground. You estimate that the kite is at an angle of elevation from the ground of about 60 degrees. Calculate the height of your kite above the ground. So in all of these word problems that we're going to get, you should be able to draw a triangle, because all of our trigonometry so far is with triangles. So hopefully you can draw this diagram. If not, I just drew it for you, on the computer. It says, while flying a kite, you let out 150 meters of your kite string. So if this was your kite, which part do you think is your kite string? Well, I mean, if you're flying the kite, and then this is the string, and it's anchored to the ground, well then this has to be, that's the string. You don't fly a kite with it directly above you. So this has to be the string. So this is going to be 150 meters, anchored to the ground. And you estimate that the kite is at an angle of elevation from the ground of about 60 degrees. So if this is the ground, I'll put a little arrow there saying ground. Then an angle of elevation is from the ground going upwards, because it's elevated, an angle of elevation. So that means this has to be 60 degrees. Calculate the height of your kite above the ground. So here's the kite. This must be the height. How high is the kite directly from the ground? So we don't know what this is. So let's call that a variable. Let's call that, I don't know, x. So how can we figure out what x is going to be? Well, if we want, we can put our letters if we want. A, B, C. So I guess this is going to be actually little a. So I want to figure out, well, what is this going to be? Well, what information do I have? I have the angle. So I know theta is equal to 60 degrees. From theta, I have this, which is what part of the triangle? Well, it's opposite the 90 degrees. So the hypotenuse is 150 meters. And I want to try and figure out what this one is. So this side is opposite of my angle. So the opposite side is A. And we don't know what A is. So looking at knowing my trigonometric ratios, I know I have opposite and hypotenuse. Well, which of the three involve opposite hypotenuse? So, ka, toa. Oh, well, so has O and H, that's opposite and hypotenuse. I'm going to be using sine in this case. Our ratio is sine theta is equal to opposite over hypotenuse. We don't know what theta is, or sorry, we know what theta is. So we said theta is 60. We don't know what the opposite is. We know it's A. And we know the hypotenuse is 150 meters. So I want to solve for A. I want to get rid of this fraction. I'm going to multiply by the denominator. Whatever you do to one side, you do to both sides. So we're left with A is equal to 150 sine 60. Put these in brackets to represent that we're multiplying them. So when I'm doing this on my calculator, a few things we have to make sure. Number one, our calculator is in degrees. We see DEG here. You might just see the letter D at the top of your screen. If you see like the letter R or rad or the letter G in grad, you have to switch it. You might have to look for this DRG button. You might have to actually type in the type of calculator you have and see how can you change it. Or you'd have to show it to me or to explain it to me sometime so we can go over it. But we want our calculator to be in degrees. I'm going to put in sine 60. And I'm going to multiply by our number, which was 150. Notice how I'm doing all of this on the calculator because the more decimal places, the better. So I don't want to round off sine 60 to 0.87. I want all of these decimals. So I'm going to keep the whole thing in there and just put my answer from my calculator there. Is equal to A. So we know the height of the kite off the ground has to be, therefore the kite is 129.90 meters off the ground. So we just had to see what we knew and then pick the right trigonometric ratio and then solve for the variable to get that answer. All right, believe it or not, last question for our word problem here. It says Martin's apartment building is 105 meters tall. From the rooftop, he spots his car in the parking lot. He estimates that the car is about 70 meters from the base of the building. If Martin's eyes are 1.3 meters from the top of the roof, what is the angle of depression from Martin's eyes to his car? Now, if you're wondering, why is this Martin doing this? Why is he sitting on his roof looking at his car? The answer is, I don't know. This is just how the question is. And if you're like, oh, Mr. Land, you designed the questions. Why did you make this question? I just thought it was a good question. And I like the little graphic, to be honest. So that's why we're doing it. So let's fill in what we know. Martin's building is 105 meters tall. So here's a building, 105 meters tall. From the rooftop, he spots his car. Here's Martin up here. He's looking at his car. He estimates that the car is 70 meters from the base of the building. Well, let's break this up. Base of the building. The base of something, like the base of a shape, is always the bottom part. And from his car to the base of the building, that's the base of the building, is about 70 meters. So this is about 70 meters. We also know that his eyes are 1.3 meters from the roof. So from the roof to his eyeballs is 1.3 meters. And we want to know what is the angle of depression from Martin's eyes to his car. So remember, when we're talking about angle of depression, Martin is always looking forwards. And he wants to know the angle from here to his car. So what we really want is this angle, not this angle. But we actually need to find this angle in order to find that angle. So there's a lot of information here. I'm going to redraw this. You'd be like, why would you draw it twice? Well, it just helps us get the answer, helps me visualize things and organize my thoughts. And it's going to take me like 10 seconds. So why not do it? So we know that from the car to the building is 70 meters. We know that the building is 105 meters. And this is 1.3 at the top. So really, the height in total that we're working with is 106.3 meters, which is just the height of the building plus the height of Martin. And then we also know that, no, that's all we really know. That's all we really need to know. So we have this much information. I have this length and this length. I also know that the base and the ground form a 90-degree angle. So we want to know what is the angle of depression here from Martin's eyes. So we're still trying to find this. So I learned something new. I'm gonna draw it again. But why are you making us draw this again? You don't have to draw this again. Should you draw it again? Again, 10 seconds, 20 seconds. And if it helps you get the right answer, spend that time. So we have this. And I want to find out what this angle is, because that's the angle of depression here. So really, if I can figure out what this angle is, then I know that these two form a 90-degree angle here. That if I figure out this one, I can subtract it from 90 to get that one. So really our goal is, can we figure out what this theta is going to be? Well, what information do we have? Well, I know from, this is my angle of reference here, I know that the 70 has to be opposite to that angle. And the hypotenuse is over on this side because it's opposite the right angle, which means that this side is beside this angle, so this has to be the adjacent. So what values do I have? Well, I know my opposite is equal to 70 meters. I know my adjacent is equal to 106.3 meters. And I don't know what theta is. So I want to figure out this angle, which will help me figure out that angle. So which of our three ratios have opposite and adjacent? So, which has a hypotenuse, so it can't be that one. Ka, which also has a hypotenuse. Toa, opposite and adjacent. So I got to use tan. Tan theta is equal to opposite over adjacent. I want to solve for theta. So I'm going to move the tan over. It's going to be the inverse of that. We call that tan to the power of -1 over 70 over 106.3. So that's what my opposite is, 70, and my adjacent is 106.3. So I'm just going to do that on my calculator. I would do tan -1, which is my second function for tan. Then put my brackets. I can just put this as a fraction. Oops, sorry, 106.3. So my calculator is going to read this as, it's going to divide these two as a fraction first and then do the inverse of tan for it. And I get 33.37 degrees. And I round to 2 decimal places. I look at the second last one, which is a 6. I look next to it, it's a 5, so this is going to go up to 7. So I figured out that this angle here is going to be 33.37 degrees, which means if I want to find this angle, I just have to do 90 minus that, and I get this. So this 56.63 is the angle measure up here. So this is the angle of depression from Martin's eyes from up here. So therefore, the angle of depression is 56.63 degrees. So your homework's at the bottom here, but I cannot stress enough that if we have trouble with this, the other stuff we're going to do is also going to be tougher. So we have to know this stuff before we move on. Again, if you want extra help, we can work out some office hours. I can give you more worksheets if you want to try more of these, and we can just do more work. But we're going to struggle in later sections if we don't understand this stuff. So please try the homework, and thank you for your time.